Why don't I flinch? Because the laws of science differ fundamentally from all other. My face. Hi guys, welcome to Science in 5. In this video, we're going to discuss Coulomb's law calculations. I got 3 questions that I'm going to tackle. Type 1 is normally when you're calculating the force between 2 charges. Type 2, you've got an assemblage of charge, more than 2 charges. You want the net force that acts on one of the charges, more or less, especially the one in the middle. Third type, again 3 charges, but this time they form a right angle. So when you're testing yourself, preparing yourself, make sure you know these basic calculations. Most of your calculations around Coulomb's law are variations. They're going to be variations of these 3. Shoot. The first one says, calculate the force between the charges. One charge is 5 nanocoulomb, the other one is 3 nanocoulomb. Now, I'm going to apply Coulomb's law. F is equal to K times Q1, Q2 over R squared, or D squared. I know the value of K is a constant. It's there in the formula sheet all the time. So this is the same as 9 times 10 to the power of 9 times. Now, when you're adding the charges, ignore the signs. Let's work out the force and then let's determine whether it's a attractive force or repulsive force. 5 times nano means 10 to the negative 9 times another 3 times 10 to the negative 9. The trick, guys, with Coulomb's law, the distance has to be in meters. The distance has to be in meters. So for millimeters to meters, you convert how? You divide by 1,000. So this is the same as 2 times 10 to the minus 3 squared. You should be able to perform a calculation like this. This is like the basic one. So grab your calculator. Let's do this calculation together. I got my calculator with me. So it's 9 times 10 to the power of 9. Then another times 5 exponent negative 9 times 3 exponent negative 9. All of that. Now, because I've got this term like this, I'd rather use a bracket. So I'm going to open a bracket, 2 times 10 to the power of minus 3, close bracket, squared. I get my force is 0,03375 newtons. Okay. Now, where is this force going to go? Because I'm just asked to calculate the force. In other words, I need to determine quickly the direction of this force. So what I'm going to do, I'm going to say this is a positive charge. It's going to be pulled by a negative. The negative charge is going to be pulled by the positive. So this is towards each other. So this force is actually towards each other. Okay. Now, let's suppose this was charge A and that was charge B. Newton's third law tells us that the force the charges exert on each other is the same. In other words, the force on A should be the same as the force on B. These forces will have the same magnitude, but they're acting in different directions. So if a question says to you, calculate the force that A exerts on B, same force. Calculate the force that B exerts on A, same force. So even if B was bigger in magnitude compared to A, Newton's third law tells us that the force will be the same between the two. Okay, the force will be the same between the two. So that is how you can do a simple type 1 calculation when you have 2 charges. Don't put the signs, they can just confuse you. Leave out the signs, calculate the force, then determine the direction of the force using the charges. You know that a positive charge will be attracted by a negative charge. A negative charge will be attracted by a positive charge. The force of attraction is the same. The force of attraction that A experiences is the same force of attraction that B experiences. Very important to pick that out quickly. So don't be hit by questions that say, oh, but the magnitude of B is now doubled. What will be the force that B exerts on A compared to the force that A exerts on B? It will be the same. Okay, so that's type 1. Let's move on to type 2.